Okey, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bertemu lagi kita untuk kuliah yang keberapa kalinya bagi subjek instrumentasi dan kawalan. Sekarang kita dalam bab 4 iaitu bab akhir lah. Di mana tajuknya ialah the industrial process and control system lah. Okey, industrial process and control system. Okey. Uh, untuk bab ni kita akan belajar lebih pada industrial process control system lah. Macam mana kita nak kawalan. Macam mana kita nak buat. Lepas tu supaya ianya boleh dikawal. Okey, untuk permulaan, elok juga kalau saya menerangkan berkenaan dengan perkara inilah. Okey. Industrial process control system ni is a system that is a set of hardware lah. Dia hardware ataupun software components yang design untuk macam biasa. Kalau instrumentasi kerja dia ialah untuk monitor, memantau, ke belakang pula. Untuk monitor, untuk regulate, subhanallah. Untuk monitor, untuk regulate and optimize various of parameters within an industrial process. Dia maknanya fungsi dia ialah untuk memantau, mengawal dan mengoptimalkan beberapa parameter supaya kawalan tu nampak lebih elok dan proses nampak lebih tersusun dan terancang. Ini juga melibatkan pelbagai sensors lah, penggunaan pelbagai sensors yang tujuan dia ialah untuk merekod data. It involves the use of sensors to collect data, to control of the process data, and then of course nowadays kita ada AI. Kita ada AI, so those programmable logic control tu supposed to supposed to have a potential to make a decision of any changes throughout the system. As we know that actuators is mostly to manipulate the process variable. Maksudnya di sini, let's say variable untuk satu perkara tu menjadi lebih sedikit tinggi or maybe critical, so sistem yang tersedia ada tu dia boleh dipantau atau dikawal untuk ianya tidak memularatkan keadaan. Let's say if it too hot atau terlalu panas, maka ianya boleh dikurangkan berdasarkan data yang dah ada. So there is a feedback system more or less. Okay. Okay, kita teruskan. Of course, the goal is to maintain desired process variables such as temperature, macam saya sebut tadi lah, temperature, pressure, flow rate, and more. Within specified time or limit, and to ensure the efficient and safe operation lah. Of course lah, at the end of the day, kita nak pastikan sistem itu dikawal untuk supaya proses itu dalam keadaan yang optimal, mudah dipantau dan mudah dikawal. So, at the end of the day, dia is a safe operation. It's a safe operation. Safe operation. Okay. So, kita ada pelbagai types of process control. Pertamanya kita ada sequential control. In sequential control, process are carried out in a predefined sequence in step. Okay, dia ada apa step dia apa kita dah define siap-siap apakah langkah-langkah keperluannya. Okay, it often used in manufacturing and assembly line where specific tasks need to be performed in a particular order. Maknanya dia banyak digunakan pada line manufacturing lah ataupun line assembly. So dia dah ada orang kata step dia. Sebelum nak buat langkah ni dah kena buat langkah A, B, C, D, E sebelum kita pergi ke proses seterusnya. So itu antara yang dipanggil sequential control. Manakala untuk discontinuous control ni also known as on-off. Maksudnya dia sentiasa on ataupun di dalam keadaan yang aktif, kita tengok dia jadi pasif balik. Dia on off control lah. This type of control, dia macam switch lampu. Involve switching the control action between two discrete states. Typically fully or fully off. Dia fully on atau fully off. It's simple and basic control stars lah. Maksudnya dia macam lampu. Kalau kita switch on lampu, nanti lampu pun menyala. Bila switch off, lampu pun terbatal lah apa kepadam. Dia discontinuous control. Okay. Manakala untuk continuous control ni, in continuous control, the control action can can be varied. Dia ada pelbagai over range of values. This type of control is used for maintaining precise and continuous adjustment in process variables. Okay. Ini dia nak cerita macam mana operating of discontinuous control. Discontinuous control. Okay. Ini dia. Ini discontinuous control. Macam mana kita nak operate dia? Discontinuous on and off action is in this type of control. The control action switches between fully and fully off states. Dia fully on or fully off. Dia black and white lah. For example, in heating system, the heating is turned on when the temperature falls below set point. Contoh, kalau dalam bilik kita ni, kita ada set point temperature dalam keadaan dew. Dew temperature tu dalam, kita kata dalam suhu badan manusia. Let's say 36 ke 37 degree centigrade. Okay. Therefore, katakanlah kita setkan supaya heater tu akan on jika dew temperature tu dah jadi low than that. Dia beyond the lowest point of the dew. Mungkin dia bawah daripada 35 degree centigrade. Maka heater pun akan on secara automatically. Okay. Dan sebaliknya lah, let's say kalau kita perlukan onkan aircon, let's say temperature yang dalam ni mungkin melebihi 37 degree centigrade, maka secara tak langsung aircon akan actively automatic akan on lah. Itu ialah cara kita nak operasi untuk satu sistem yang discontinuous control atau kawalan yang tidak bersambung. Okay. Ini ada sikit lagi penerangan berkenaannya, iaitu on and off action control. This control action is similar to the discontinuous on and off action, where the control action switches between fully and fully off. It's often used in basic control tasks and can result in some oscillation around the set point due to the abrupt changes in control action. Maksudnya dia ni, ialah bila kita fully on, macam engine lah, kita masuk daripada gear 4, kita tukar terus pergi ke gear 2, dia memang drastically turun. Kan? Jadi set point tu pasti akan berlaku fluctuated. Kadang ada dia kejap naik, kejap turun, kejap naik, kejap turun. Sebelum dia stable. Okay. So itu antara dia punya, orang kata apa, limitasi lah. Limitasi bagi perubahan, bagi tindakan kawalan. Okay. Nah, ini pula operating principle of continuous control action. Proportionate control ni. Proportionate control ni adjust the control action based on differences. Based on difference between the desired set point and the current process variable. Maknanya dia akan adjust. Sekiranya set point kat sini, and then kita mungkin overshoot sedikit lebih tinggi. So proportionate control ni dia akan cuba control supaya dia menghampiri set point tu. Okay. The control action is proportionate to this error lah. Maksudnya kalau bacaan pertama tu dia ada besar dia punya perbandingan tu, maka error yang tu akan dibaca dan dia akan proportionally control according to the error supaya bacaan kali kedua dia akan lebih merapati set point juga. Ya. Okay. So ini integral action. Okay. Tadi proportionate, ini integral action. Integral control focuses focus in eliminating steady state error by integrating the error over time. Maksudnya ni dia akan integrate. Kalau tadi dia akan adjust berdasarkan apa feedback yang dia dapat. Ya, dia akan adjust. Yet for the integrate action, dia punya case dia akan, apa dia buat? Dia akan, apa kita panggil, integrate the error over time. Let's say dia dalam 10 saat, so dia akan integrate the error dalam masa 10 saat. Of course, it accumulates the past error and uses this accumulated error to adjust the control action. Integral control helps in addressing any long-term deviation from set point. Maksudnya, tadi tu proportionate control, dia dah baca ada error, so dia merapati. So, untuk merapatkan lagi ke set point tersebut, ni integral action akan ambil peranan lah. Dia akan play role by minimizing deviation between the set point tu. Okay. Manakala derivative action, derivative control ni consider the rate of changes of error. Dia akan kira kadar perubahan atau kadar perubahan bagi sesuatu error tersebut. Okay. Dia akan anticipate lah, dia akan mengagak anticipate how the error would change in the future and adjust the control action accordingly. Okay, derivative action helps in damping oscillation and reduce the overshoot. Maksudnya kalau tiba-tiba dia overshoot, tiba-tiba tinggi overshoot, dia tiba-tiba contoh okay, oops, ni ada naik ni kan, subhanallah, ni kenapa ni? Dia overshoot, dia naik tu, that overshoot tu akan dikontrol oleh apa tu, akan dikontrol oleh derivative action. Overshoot of the system tu dia akan control. Okay. Okay. Dia akan control Alright. So, dia contoh macam ni. Saya lukis. Okay. Let's say ini ialah kita punya respon. Dia naik, tinggi. So. Oh, dia stable. Somehow, kita punya set point adalah kat sini. Okay, ini ialah set point. So, fungsi derivative action ni ialah dia cuba akan kurangkan ni. Ini dipanggil, keadaan ini dipanggil overshoot. Overshoot. So, derivative action ni, this derivative action trying to overcome this overshoot. It try to damp it a bit. Damping, dia memberatkan. Oscillation, ni keadaan ni disebut oscillation, and then dia reduce the overshoot. Itulah fungsi derivative action. Okay, kalau kita gabungkan ketiga-tiga control action tu, kita dapatlah nama dia, apa tu panggil tu, PID action. Okay, PID control combines proportional, integral and derivative action to create a control action that is sensitive to the current error. Okay, of course lah, mesti dia tertanya kan, P ni proportionate, I ni integrate, D ni derivative. Of course, this whole thing they got numbers lah. It goes by magnitude. Mungkin ni P ni 10, I ni mungkin 5, D ni mungkin 3. And then kita akan cuba lah combine those three magnitudes ni. Ni kalau ini panggil magnitudes Those three magnitudes untuk kawal kita punya sistem respon. Ni naik. Ni nak kawal sistem respon, kita akan pakailah ketiga-tiga variables ni. Okay, of course, saya rasa semua pun dah tahu. Let's say ini keadaannya, ini ialah input. Okay, ini kita punya set point. Let's say kalau lari pada set point tu, so percentage of error ni akan patah balik untuk di-accumulate balik, untuk dilihat balik, dan dia akan cuba merapatkan supaya dekat pada kita punya set point. Akan matlamat lah supaya tak jauh daripada set point tersebut ya. Okey, so saya teruskan lagi. Untuk stability of continuous control action, okay, in the context of control system, stability refers to the behavior of the system over time. Stability tu ini. Saya rasa saya dah fikir banyak kali dah. Let's say dia overshoot, dia naik and then dia stable kat sini. So this one is stability. Dia stable. Maksudnya sistem tu dalam keadaan stabil. Of course, yang akan menjadi masalahnya, let's say it's over time, this one is response lah, whatever response you want to put, you put. So how well the response of the system might going to stable over the time here. Let's say ini pada 0 second to 10 second, let's say, and then 10 second to 30 seconds here. So more or less the system would took at least about 10 seconds before it reach stable state. And then for the stable state, you're going to sustain about 20 seconds. Ni 30 tolak 10. So you got 20 seconds. Okay. For continuous control contraction, such as proportional, integral, and derivative control, stability is a crucial aspect lah. Maksudnya kita tak nak lah lampu, kalau kita buka lampu tu dia berkelip-kelip tu, tak maulah. Dia buka lampu dia terus cerah lampu. Tutup, terus tutup. Tak naklah dia ambil masa yang lama untuk dia mengeluarkan cahaya. Something like that lah. Secara analoginya. So saya teruskan lagi. Untuk proportional control stability, in pure proportional control, stability can be achieved for certain system, but it might not be sufficient to eliminate oscillation completely. Maksudnya, dia sesuai guna proportional control stability ni, sesuai. Ni sangat sesuai. Sangat bagus. However, it might not be sufficient enough. Tidaklah secukupnya, sufficient enough. Not enough. Okay. To eliminate oscillation completely. Tak boleh nak buang oscillation. Especially in cases with larger time constant or delays. Okay. Manakala untuk integral control stability, okay, integral control can improve stability by eliminating what? By eliminating steady state errors. Okay, ni kan steady state errors ni macam ni. Ni oscillation tadi dah belajar, lepas tu dia lama sini kan, set point dekat sini. Ni kita panggil steady state, subhanallah, error. This one is called steady state error. Okay. Namun, however, excessive, kalau kita guna ni terlalu lebih, integral control ni, if we use it more or overuse it, okay, excessive integral action can lead into integral wind up. Dia jadi lebih besar. Atau dia boleh jadi lebih besar. Where integral terms accumulate too much error, causing overshoot and oscillation. Dia akan still oscillated and overshoot. Kalau kita menggunakan integral control stability tu, that magnetic tu kita pakai terlalu lebih. Kita adjust dia terlalu lebih dan akan memberi masalah lah pada kita. Okay, and then for derivative control stability, derivative control can help dampen. Dia boleh mengurangkan ni, dampen, dia mengurangkan. Okay, dampen oscillation and reduce overshoot. Tapi kalau kita terlalu guna derivative action ni, can amplify noise and lead to instability. Dia boleh amplify noise. Dia boleh macam ni, and then lead to instability. Dia tak jadi stable lah keadaannya. Okay. Dia boleh jadi keadaan yang dipanggil instability. So keadaan ni kita tak mahulah. Okay. So ini ialah kita panggil procedure for tuning controllers. Okay. Controllers tuning involve adjusting the parameters of the control action to achieve the desired control system performance. Ini biasalah. Dia kalau kita tune tu, dia dapatlah apa yang kita nak matlamat kita. Proper tuning is essential to achieving stability, minimizing overshoot, reducing settling time and maintaining robust control system. Okay. Common method for tuning controllers include apa dia? Manual tuning. Manual tuning ni maknanya kita guna kata hati lah. Let's say kita ada P, kita ada I, and we got D. So then we're going to adjust PID ni accordingly supaya ianya mencapai piawai atau goal kita tu. Okay. Of course lah, in a way to find the finest tuning tu is a time consuming. And not always yield to the optimal result lah. Tak semestinya dia akan memberikan jawapan yang very optimal. Okay, the other way is kita guna Ziegler-Nichols method. Okay, this method involve a step test to determine the system's ultimate gain and ultimate period. Nak tahu berapa gain system tu and ultimate period dia. Which I used to calculate the proportional, integrate and derivative system. Maksudnya dia ada formula dia lah. More or less idea dia, konsep dia ialah dia test dulu sistem tu. Nak tengok sejauh mana dia boleh pergi dan jauh mana dia boleh sampai. And then from there, barulah dia akan tune balik, retune balik guna Ziegler-Nichols method ni supaya dia dalam piawaian yang kita nak. Okay. Manakala untuk Cohen-Kuhn method ni, this is another tuning method that involve analysing the system response to a step change and using specific formula. Dia senang kata yang ni ada formula sendirilah. This one they got their own formula. And Cohen and Kuhn method pun dia ada formula tersendiri. Tapi konsep tetap sama. Dia akan test the system accordingly. Dia akan test tengok sejauh mana dia boleh pergi, besar mana dia punya gain tu, jauh mana dia punya period. Dan from there dia akan adjusting the system accordingly lah. Okay. And lastly, at least lah kan, lastly the model-based tuning is more advanced method. They're using mathematical model of the process, in order to simulate and optimize the controller's parameters. Okay. Now is operating of pneumatic PID control. A pneumatic PID control is a control device that uses pneumatic signal to adjust the process variable based on proportional, integral and derivative contraction. Okay. So pneumatic derivative control, kita continue lah. Okay. It's a derivative controllers provide a control action proportional to the rate of change of the error signal. In pneumatic system, this might be implemented using flapper nozzle mechanism. Apa benda cerita ni? Okay. The derivative controller provide control action. Biasanya dia akan fokus pada proportional control action lah. To the rate of the changes of the error signal. Okay. In pneumatic system. Let's say kalau dia punya pemanjangan silinder tu tak sampai yang kita nak. So dia akan adjust balik supaya dapat piawainya. Okay. Nombor 2 ialah operating principle. The error signal representing the difference between the set point and the process variable in fact to the flapper nozzle system. Control action. Okay, sekejap Ini sedap. Okay, control action. The flapper move in response to the changes in the error signal, adjusting the airflow and consequently the pressure. The rate of the change of the error determines the magnitude of the control action. This anticipates changes and helps in damping oscillation. And how it been applied, the application often used with another controllers, rarely on its own, as it only considers the rate of changes and not the magnitude of the error. Dia akan melihat kepada kadar perubahan saja, tidak kepada magnitude error itu sama ada besar atau kecil. Dia control rate saja. Okay. Tadi kita dah ada derivative control, ni dah pneumatic PID controller kan, ni derivative controller. Then kita akan tengok pada integral controller dan keseluruhannya lah. Okay. So ini ialah pneumatic integral controller. Ni I controller, ni D controller. Untuk I controller, An integral controller provide a control action proportionate to the integral of the error signal over time. Maksudnya apa dapatan yang dapat tu dia akan apa? Dia akan bahagikan over time. Dia akan integral, bukan bagi, dia akan integrate over time. Dia akan integrate over time. This ensure the persistent error are gradually corrected. Ini macam saya tulis lukis tadi tu, benda yang sama. Ni kalau oscillated, and then ada error, so dia akan time by time dia akan fix the error. Okay. Operating principle, a pneumatic integral controller may use the value of diaphragm system lah that accumulates pressure over time to proportion the error. Maksudnya dia guna value atau diaphragm system untuk dia semak balik supaya dia proportional to the error. And control action, as the error persists, the accumulated pressure increase, leading to the greater control action. This will continue until the error is eliminated, providing automatic correction for steady-state errors. And then for the application, commonly used in system where zero steady-state error is required, but can be slow to respond to sudden changes. Okay. And then a PID for the pneumatic PID controller, ini keseluruhan lah. Okay. A PID controller combines the action of proportionate, combine PID controllers to provide control response that consider the current error, the history of the error and the rate change. Secara operasinya, pneumatic controller might combine the element of both derivative. Macam tadi lah, kalau proportionate tadi dia guna flapper nozzle mechanism, mungkin digabung sekali bellows and diaphragm secara bersamaan atau secara tidak bersamaan. Okay, of course ideanya ialah dia respond to the present error. More error means more control action. Okay, integral action supposedly respond to the accumulation of past error. If the error has been present for extended period, it will accumulate and the controller will respond by changing the control output in relation to the steady state error. Okay. Derivative action, they predict future error by looking at its rate of change and provides a control action that counteract with predicted error. And this application used in many industry and commercial application where the balance responsive stability and steady state accuracy is required. Okay. So untuk for chapter 4, I think if I may recap, is it focus more on controlling this process. However you try to control the process, how well you going to control the process. Of course, they got couple of techniques, couple of method, and then of course it involve a lot of processes around, and then a lot of controllers to be playing off. Therefore, care need to be given lah, attention need to be given for this controller topic where somehow it might want to be very useful for you or your future lah. Either in industries or either you going to further your study after. So I'm going to end my presentation now, whereby I'm going to continue for this topic after. I think maybe we're going to discuss it during our face-to-face class, where I believe this chapter going to be is being part of the test too. Okay, so sampai di sini saja. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih.